I'm gonna back up to the scale real quick. What would you call this kid, the 33-pounder?
An outlier.
Say that again.
90th percentile.
90th percentile. Other votes. Chubby. Statistically, what would you call this kid? Maybe he is. Maybe he's just dense. Not mentally dense, just a dense. I coached my son's soccer team. There was a 7-year-old last Saturday that was easily 8 inches taller than every other 7-year-old on the field, including the girls who are taller on average at this point than the boys. And he was playing like he was in 5th and 6th grade. That's this kid that's over here on the scale, just at that point in the growth. So maybe not chubby, maybe just more developed. But statistically, what would you call it? I got 90th percentile? 100th percentile?
Outlier.
An outlier? Oh, I love all these words. By the definition we just agreed on, he'd technically be the 99th, wouldn't he?
Yeah.
Because remember, if we're going by the definition that percentile rank is the percent you exceed, he can't exceed himself. He's as heavy as he is. So technically, he's the 99th percentile because he beat out 99 out of 100. Is that fair?
Yep.
I'd go with 90th percentile, Aaron, for these guys here, because they exceeded 90 of the 100. They'd be the 90th percentile. This is the 90th. This is the 99th. We already know Max was the 80th. You see how it's not linear? 99th, 90th, 80th. We can keep going all the way down if we needed to. You guys already did a few of them, right? It's not linear. It's based on how big the bars are in the graph, whether it's a sample or a population. But some people, now keep that in mind, what would you call this kid? Tiny. Good answer.
20th percentile.
20th, why 20th percentile?
He's so far outside.
Ah, technically speaking, which percentile is he by that definition?
It's a 0.
He's the 0th.
He is.
Yeah.
Think about it. Remember the definition of percentile, Alicia?
Because he doesn't exceed anybody's weight.
He exceeds nobody's weight. He doesn't exceed anybody's weight, right? But, and this is why I say, I say but, however, some statisticians, they do a slightly different calculation. They say, instead of calling this kid the 0th percentile, they say don't just count the ones you're above, but take half of those that are as heavy as you and throw you in there too. So in other words, all the 20 pounders are just as heavy as all the other 20 pounders. So let's just count them as part of the calculation. I'm not saying this makes sense. I'm saying this is what gets done sometimes. So if you get something like the 99.5th percentile or the 99.99th percentile, very often what has happened is you are being grouped into another ranking system. I don't want you to get hung up with that. Just realize it exists out there. If you're getting a percentile rank, always ask how it's being calculated. I guess that's what I'm getting at. There's a uniform definition for how to calculate an average. Do the math. I love that. Do the math. There's a uniform calculation for how to do a standard deviation. There is not a across-the-board calculation for percentile rank. This, in my opinion, is the most clear way of determining it. You've got a whole bunch of data, you throw a line down that separates a certain percent from the rest of the percents. That's the simplest way to envision it. And honestly, they do a pretty darn good job of, if you can process that in that way, it's a pretty darn good way of doing it.
Yeah, the second one makes a lot more sense than that first.
Well, technically speaking, it's the same thing, but this is more general. So I'm glad the general makes more sense to you, Faith. Thank you. That's good. And that's why I like thinking of it that way, because I think it's the clearest. Personally, I think it's the clearest possible definition. Fair? Andrea, question? No? Okay, sorry. I see motion. Now, I do want you to realize that, sorry, it's ADHD. There are certain graphs that lend themselves to percentile rank calculations better. Here's one of them. Here's one of them. If you look at this, it looks exponential, very nice. They often do. They often do. It's very nice. Or logistic. Or logistic. But this is the same data that you just looked at. But good. What? What you talking about? What you talking about, Willis? But how? How is it the same? It looks nothing like it. How is it the same? Read it carefully. Read it carefully and read the stuff that I put in color because I wanted it to pop out. What are you saying, Andrea? What are you saying?
Isn't it by frequency?
Technically speaking, it's by cumulative frequency. And here, good. I changed the frequencies. In the old one, look at the old one. Number of boys, yeah? Number of boys. So obviously what that means is number of boys that weigh 24 pounds, number of boys that weigh 27 pounds, number of boys that weigh 30 pounds. Yeah? Good. Now, if we go forward to this, it's number of boys at or below that weight. So, 20 pounds. Remember how many kids were at that weight?
3.
I think it was 3, yeah? It goes to 3. 21. There was only 1 kid, I believe, in that range, I think. Why is this 4 now?
Because you have to count the 20 calories.
Yes, Riley, because the 21 or less. So what you're getting is that weight and everything below it in that bar. And Andrea's already to the far right side. Good for you, sister. Because when you go to the far right side, 33, how could 33 be up at 100?
Because it's all.
Because every single kid in the sample was 33 pounds or less. This is very helpful for percentile ranks. Because you can go right to it and go, oh look, 30 pounds goes up to 80. That means 31 is the dividing line between 80 and 20. That's where it comes in handy. As a matter of fact, it comes in so handy that they give you this chart at the pediatricians, which is that graph. Now this is a lot to look at. Just FYI, this is a ton to look at. But this is how you can find max. Watch this, this is kind of fun. So it's boys birth to 36 months. They actually have this out to 20 years. It's a crazy graph. I want to have you guys look at it later on in the course when it becomes more sensible to look at it. Birth to 36 months, so this was just 2-year checkup. So we're at 24 months, right? 24 months, right there. Now, you've got length and weight all on the same chart. So you have to kind of be careful about what you're looking at and making sure you're looking at the right thing. So we're looking at weight. So I got to go to 24, and then I have to find his weight. Now, we just agreed he was 31 pounds, right? 31 pounds. So here's 28, 30, 31. So I'm going to come, is that pounds? Yeah, kilograms over here. So I go 24, and I go up till they intersect, which is right about there. Right about somewhere in there. Now, if you look at the percentile lines, which are drawn off here, and there's a reason why those percentile lines are there, but we're slowly developing ourselves to get to that point, why they're not spread evenly. 75th percentile, 90th percentile. Look where he's sitting. 80th percentile. This is a chart, I mean, you know it very well. You take the birth, the age, and the weight, you intersect it, you draw a dot, and you say there's your kid's percentile. Whether it's length, whether it's head girth, whether it's weight, whatever it is. Why am I telling you this story?
Because it's cute.
Not cute. Infuriating. Here's what happened. Well, my son's adorable.